Hi everyone, in this video we are going to discuss the combustion reaction. So let's start off by looking at a very generic form of a combustion reaction. So we always start off with some source of fuel, we treat it with oxygen, and we then create carbon dioxide and water. Again, this is generic form, so we obviously can have a number of different products, but we're just looking at the generic version. Alright, so let's start off by looking at the fuel. In this unit, we're primarily going to look at fossil fuels. And so there's two things we need to understand about fossil fuels at this point. We'll go into it deeper later. But essentially, fossil fuels take hundreds of millions of years to create. So every time you burn a piece of coal, you need to realize that every single piece of coal took hundreds of millions of years to actually be created. Now, the second thing, which is even worse, is that this form of energy or this source of energy is non-renewable. So all that means is that the second you burn a chunk of coal, we're done with that source of energy or source of fuel. There's no way we can ever regenerate that piece of coal. So that's kind of a problem. All right, let's move on to oxygen. We know a lot about oxygen. We know that 21% of our atmosphere is oxygen, which is great because as humans, we need to breathe oxygen. We also know that oxygen has a very strong double bond. And so when oxygen exists in our stratosphere, it's able to absorb that UVC radiation or that really high energy electromagnetic radiation and protect our skin from dangerous rays. So that's actually really good. Carbon dioxide we've also discussed. We've seen an increase in our carbon dioxide concentration since the year 1750, so essentially since the Industrial Revolution. But the increase in carbon dioxide essentially is leading to an increase in our temperature, and so this is referred to as the enhanced greenhouse effect, or otherwise known as global warming. So every time we burn a fossil fuel, we are contributing to the warming of our planet, in other words, global warming. All right, water we know a lot about. I'm not going to spend any time talking about that. There's a generic cycle where we have water, it rains down from the clouds and evaporates back up. We have a very, very common water cycle on our planet. Now let's move on. Every time we burn fossil fuel, every single time, we are introducing new pollutants into our atmosphere. So let's be specific here. We have mercury, we have soot, we often have sulfur dioxide and nitrogen dioxide, which is really bad for us. And so the reasons these are big problems is because a lot of times they cause adverse health effects. We're just going to put health problems here. So a lot of times it has to do with the respiratory system, so your lungs, maybe your throat and whatnot. And then also these two specifically, your SO2 and NO2, can help create acid rain. So these pollutants are called pollutants for a reason. They're really bad for us and they're really bad for our environment. But now, after all this being said, why do we do this? Why do we light our fossil fuels on fire? And it simply has to do with the fact that a combustion reaction is an exothermic reaction. So that means we are releasing energy. So let's get that word down because that's super important. So we are talking about exothermic reactions. Exothermic reaction is simply a reaction that releases energy. In other words, your energy is on your product side. If I'd written on the reactant side, that would have been considered an endothermic reaction. But combustion is an exothermic reaction. The reason why we set our fossil fuels on fire is because they release energy. Okay, so it's super important. So now, this releases energy in the form of potential energy. So sometimes you'll see potential energy abbreviated as PE. So let's kind of check in of our current understanding and see what we know about our two main sources of energy. So there are two main types of energy. It is potential and what? Did you get an answer? Hopefully you did, and the thing we were looking for, or the word we were looking for, was kinetic. So the main two sources of energy are potential or kinetic energy. So let's talk about each of these. Potential energy is essentially the energy that is stored in position. And so specifically, we talk about this in chemistry with the energy that's stored within bonds or within a molecule. And so essentially, when we talk about this, we would say that the potential energy is equal to your mass times your gravity times your height. So the higher something is, or maybe if you're talking about steps, if you're on your first step and you fall off, it's not going to be that big of a deal because you have a low potential energy, you're low to the ground. But if you're on the very, very top step and you fall off, it's going to be a lot more painful because you're much, much higher, and so you have a lot more potential energy, or more area to fall, essentially. All right, the opposite one of potential energy would be kinetic energy. And kinetic energy is essentially just the energy of motion. And a lot of times I like to use the word movement, but essentially anytime something is moving, it has motion at all, we are now talking about kinetic energy. And so kinetic energy is usually talked about in terms of 1/2 mv squared. So m is your mass, and your v is your velocity. Okay? And we're not going to go into this too much, but I 100% expect you to understand the differences between the two types of energy and be able to look at examples and describe which one has potential or kinetic or perhaps a combination of the two. So let's ask a question and see if we understand this. Would you rather be hit by a baseball or a ping pong ball that is moving at 100 miles per hour? Okay, that's really fast. What do you think? Ping pong ball, baseball, go. Did you get an answer? Hopefully you did, and there's definitely a correct answer with this one. You would want to be hit with a ping pong ball. You do not want to be hit by a baseball moving at 100 miles an hour. That would be an absolute disaster and be quite painful. Now, why is that? What is different about the two? A baseball has more, significantly more, blank energy. What type of energy? Potential or kinetic? Go. Did you get an answer? Hopefully you did, and the correct answer is kinetic energy. A baseball definitely has more kinetic energy. Remember, the relationship with kinetic energy is 1/2 mv squared. So the more mass something has, the more kinetic energy it will be able to have. A baseball ball is significantly heavier than a ping pong ball, which is why if you have a choice to be hit by a ping pong ball or a baseball at 100 miles an hour, you're definitely going to pick that ping pong ball. Take care of yourselves, drink water, have a fantastic week, guys.